All right, for the first time ever on this stream, we're going live on time. That never happens. We're always at least 5 minutes late. We're almost, oh, now we're a minute late. We're good. All right, so hi, folks. I'm Nate. You recognize me. You know why I'm here on this channel, but tonight is not an Iron Sysadmin podcast. Tonight, we've got the DefCon group that I help organize. Needed a place to stream some talks tonight because, of course, we're meeting virtually because of, global pandemics and whatever. So tonight we have two talks lined up. One of them's from me, which will be later. We talk about 3D printing. And one of them is from my friend Dan here, talking about reverse engineering wireless sensors. So first, I just want to get out of the way. If you're in the Northeast PA region, or even parts of Jersey, or maybe even New York, depending how far you want to travel, you should definitely join our group. We meet, well, when there's no pandemics, we meet the first Wednesday of every month at an awesome brew pub in Easton called Two Rivers Brewing. If you've never been there, you should go. They have awesome food and awesome drinks. And I'm going to get out of the way, and Dan can go ahead and give us his presentation. So, just
All
one
right.
second
Hopefully I'm
here.
coming over.
You can hear, and now people should be able to see your slides. So,
Okay.
off you
Yeah.
go.
Hey, I'm going to talk about reverse engineering wireless sensors. So why would you want to do this? Well, be honest, what else is there to do right now since everyone's stuck at home? You get to play with software-defined radios, universal radio hacker, and other hardware. It's kind of a puzzle, and you can add support for an unsupported sensor in RTL_433, which is a piece of software that can decode various sensors, key fobs, etc. So the sensor I wanted to reverse engineer is a soil probe that gives temperature and humidity. We know it's an ambient weather TX3102, and it measures soil moisture and temperature. We know it's at 915 megahertz, it has 7 channels. Channels is in quotations because it's not really a channel, it's just a bit that's set to a different value, or a couple of bits that are set to a different value. It has a reset button in the case, and it has a transmit now button, which forces it to make a transmission. And from this image, you can see that this is the probe. I have it hooked up to a variable power supply so I can lower the voltage to try to get it to send different data. If the voltage is low, it might report low battery, etc. I'll get into those details later on this in the slideshow. So this was my improv bench you can see GQRX running on the screen. Sorry, it's not actually a screenshot. And you can see the antenna from the RTL SDR. The picture doesn't actually have the SDR in it, unfortunately, and the other picture is from the other slide. So when you're going to try to reverse engineer something or a wireless sensor, a good place to start is looking up the FCC ID on either fcc.io, the FCC's website itself. Anything that's legally allowed to transmit in the US should have an FCC ID. If it doesn't, like you got some cheap sensor from China, it might not, so it's technically not legal to use in the US. But after you look up the FCC ID, you can figure out what frequency it's on. You can see internal or external photos, the manual, the operation frequency, the test report that's done by the laboratory that would certify it for FCC compliance. And sometimes you can actually get detailed information about the device if they forget to submit a request for confidentiality, and you'll actually have block diagrams of how the device actually operates. So after you figure out what frequency operates on, you tune to it. So ignore the image. This is the local weather frequency here, 162.55 megahertz. But I would have tuned this to 915 megahertz and then hit the transmit now button. You would have seen in the waterfall, you would have seen the transmission. Next step is you can open up Universal Radio Hacker, which is a piece of software that does a lot of the figuring out of things for you. It can tell you what the modulation is. It can try to figure out the code for you. So after you figure out what modulation it's using, you can tweak some parameters, Universal Radio Hacker. I'm not going to go into the details of using Universal Radio Hacker on this talk. I actually just used it to identify the modulation, and then I switched back to using RTL433 to do the decoding. So, and also I had some issues with decoding. It was decoding backwards for some reason. I didn't feel like messing with it. So at least now I know it's FSK modulation. So RTL 433. It allows you to have a general decoder, so you can actually specify a bunch of parameters for stuff that's not already in the program. By default, there's like probably 200 or 220 decoders in it now that'll decode various sensors, weather stations, tire pressure monitors, whatever. So in this screenshot, you can see that I specified, the frequency. I gave it a name. I said it's a frequency shift keying, and I gave it the S and the L parameters. That's for short and long uh, transmissions for ones and zeros. An R of 1,000. So after 1,000 microseconds of no transmission, it'll reset. And you can give it a preamble bytes, so it'll grab only that transmission. So this transmission starts with I don't know what's that, 9 A's or whatever, 40 bits or 40 bytes of A. Um, and yeah, you can set the gain, which is 42 dBi. You can tell it to write to CSV. And this S known is it'll write the known. If it's a known transmission, it'll write it to that file. And on the bottom of the image, you can see that it decoded a bunch of bits, and that's an actual valid decode. I'll get into the CRC and all that stuff in later slides. So now that we actually have it decoding, which actually this sounds like it took like 5 minutes, this actually took a few days, actually probably a little longer than a few days to do, but so now you have it decoding, you want to generate data. So you try to vary as many inputs as you can. I didn't have the actual receiver for this device, so I didn't know actually what it was sending, but I knew it sent temperature, humidity. So I varied the temperature by putting it in the freezer or putting in a cup of water. I varied the humidity by tricking it with just a pair of alligator clips and shorting it so it would have 100% continuity. So it would report 100% humidity. I could also vary the voltage to try to get it to trigger a low battery warning, because that was one of the features it said it had. But when you're doing this with any scientific experiment, you only want to change one variable at a time and try to keep everything constant, which I guess inside you can kind of keep the temperature constant, but it will fluctuate a little bit. So it was a little difficult to figure out the bits, but later on I'll explain the bits. And I still didn't actually figure out all the bits, but I figured out enough to make it work. So now, yay, let's generate some data. So you can see from this transmission, a lot of bits are staying the same, but you can see that there's a value that's starting at like 23, 23, 22, 40, etc. That was actually the temperature of the probe. So yeah, figure out the bits. It's like looking at the matrix, and you're going to be staring at the screen for a long time. And then once you figure it out, you're going to realize they weren't as smart in transmitting the data as you thought they were. Like, for example, you can see towards the end that 2342 is actually 23.4 degrees Celsius. It wasn't actually encoded at all. It was just a lazy, base 10 representation in hex. And there's this, now that I have the data decoding, I wanted to figure out what the CRC was so we would know if it's actually a valid data. So I ended up writing a script that cycled through a bunch of the arguments for this program called reveng, which has a bunch of CRC functions built in that it'll try brute forcing all the polynomial variables and the other parts of the CRC until it figures out what CRC it's using. One of the hard parts was figuring out what bits on this were actually the CRC, because the CRC was actually at the beginning of the packet or the beginning of the data and not the end. So I was assuming the last few bits were the CRC, which was completely wrong. So that was one of my hangups I had on this. So after spending days and time figuring out the bits, this is what it came out being. So the first 6 bytes are the preamble or the sync, so it's just a bunch of A's. Then there's usually a code word. In this case, it was 2D4. Then after that was the 4 byte CRC, which is X modem. Then there were a couple of other bytes after this. I don't know what they meant. They stayed fairly constant. They didn't change. So I'm assuming it was like a device type or a family ID. The next set of bytes was the channel. So it was 1 through 7. There was a little rotary switch, or not a rotary switch, a multi-position switch you could turn on the device to tell it to change the channel, and this number would change. And then a bunch of blank bits here, which might be for other devices because they make other equipment that measures temperature. They also have a pool sensor for the pool water temperature. So they may be using those bits there for that. And then after this is the temperature, 23.4 degrees. The next after that is it's a battery status and the sign. So when the battery's low, this value changes, or if the value is negative, this has another representation for that. And then after that, you have the soil moisture, which is 0 through 16, or 1 through 16, which correlates to 0 through 100. So each one's like a step of, I don't know, 7% or something like that. And there was also, was interesting, there was another few check bits on the end, which was it was a sum of the bits and it was XORed with FF, which it's kind of interesting that they have a CRC and this XOR validation. I don't know why they did both. And then after that, I ended up, writing some C code for RTL433 and implemented a decoder in it, so you would actually, see valid data and see what, what the sensor was reporting. And here it is running the decoder against a bunch of samples I took, where you get the humidity percent, the temperature, the battery's okay, the ID was the channel, and it has the integrity check for the CRC. So if it passes the CRC, you'll see the values in RTL433. Okay, what are some lessons learned from this? Don't assume the CRC is at the end of the packet, but who really puts it at the beginning? I don't think I've seen many things that do that. And another thing is RevEng expects the CRC to be at the end of the packet, so you have to reformat the data if you want to use that to try to brute force the CRC. And also, I didn't think the temperature would be encoded in hex, but human readable, so it was the base 10 representation in hex for the temperature. Another thing is you got to keep good notes, because you'll forget what you did 3 months ago when you give this presentation. So I had to refresh myself on actually how I did all this stuff, and obviously take better notes. So some unanswered questions. What are the unknown bits? Or do I care because I got the data I wanted? Why couldn't I get the proper decoding in Universal Radio Hacker? And why is there a CRC and a sum8 in the data? Why are they doing 2 different ways to verify the data? So some tools and resources to do this. FCC.io. It's just a better way to search the FCC. It'll pull up the page for the device right away instead of having to navigate through the confusing FCC website. GQRX is a open source Linux based SDR software. There's a ton of other ones for Windows you can use too. An RTL SDR dongle. It's a cheap SDR. You can get them for about $20 now, maybe cheaper. As I said, Universal Radio Hacker. It's a tool for wireless protocol exploration. It does a lot more than just capture. Once you figure out the encoding, you can actually use the fuzz and some other fun stuff too. RevEng is a CRC/checksum brute forcer. I mentioned RTL433 already. It can receive all these different sensors, and you can tell it to listen on whatever frequency your SDR supports. So more than just 433 and 915 megahertz. Another good thing to have is a variable power supply and some test clips, so you can actually use the device without using the batteries, and you can vary the voltage to try to get the trigger a low battery warning or anything like that. I think that's my last slide. Yeah, that's my last slide. So I don't know if anyone wants to heckle me or ask any questions.
I got a question. What CRC stand for? I can't recall.
Cyclic redundancy check. I think it's.
Yes, cyclic redundancy check.
I wouldn't say it's an algorithm that just verifies that the bytes are. I guess you say it's almost like a hash. If a unique input gives you a unique output, and it should be the same, for anyone who calculates it.
It's a type of hash very susceptible to change in the data.
Okay, yeah. So they're using it for just making sure the data was the same.
Right. Yeah. If I changed 1 bit, the CRC wouldn't match. So you would know there's either CRC's wrong or the data's wrong. Something's wrong. It's not a valid packet. There was an error in decoding.
Gotcha.
Yeah, definitely kind of interesting that it's doing both a CRC and a sum8.
Yeah.
Yeah, I thought so.
That's kind of odd. I wonder did you happen to play around with trying to manipulate the data and seeing if they both fell off because of you manipulating it? Like it just didn't accept it?
Well, I didn't have the base station for this, so I didn't know actually what it was sending. So that made it infinitely harder to figure out. But I suspect maybe they reused some code from some other sensor and they just slapped, the CRC on it and just left it. Because I don't think you would need both, because a sum 8 would be good enough for a CRC validity check on this too. So I guess that might be more susceptible to actually passing a check than the CRC, even if it was good data or bad data. But
Nice. And what kind of bench power supply do you use for this?
I use this cheap like $20 thing that you saw in the picture. I don't remember. Let me see if I can scroll back. I could find it out and post it in the chat.
Yeah, I'd be curious.
I guess it's really not a bench power supply. Where's the picture? Go back. I think I just locked my machine up.
Huh?
Yeah, it's not liking me.
You get a +1 for using that meme, by the way.
Oh yeah, obviously.
You also get a +1 for locking up your machine.
Yeah, locking up your,
Yeah,
machine,
so
your
this
machine in the
thing,
middle
I
of the
don't-
talk. Yeah.
Yeah, so I guess you can count it as a bench power supply, but I actually have a legit bench power supply on my bench. That's
That little thing there with the
that
display
little
on it and the
thing.
knob.
Yeah.
I mean,
Oh,
if
nice.
it's-
What does that go up to? Like 0.5 volt?
It goes up to whatever your input voltage is. So I think you can take
that
up to
make
30
sense?
volts into this. So
So
like
it's
a
just a
9
pass through.
yeah, it's basically just a step down. It's not like a legit bench supply. It was
So it
just what I had
doesn't-
laying around.
All right, cool.
But yeah, I could post whatever that is and my actual bench power supply I have, the information.
Cool.
Pretty neat stuff.
Anybody else? Questions, comments, cliches?
And this just touches the surface. Like I didn't go into all the, crazy grunt work. I don't know what else you want to call it to actually figure it out. It's just maybe I'll give another
definitely
talk
puzzle.
on
It's really cool
actually.
shit.
Maybe I'll just give a talk on actually how to use Universal Radio Hacker, even though there's tons of YouTube videos on it already. But
Talks are better than YouTube videos.
yeah,
Yeah.
Yeah, that would be a good idea, especially for like looking into Z-Wave and stuff like that. I imagine that's applicable there as well.
could use it for Z-Wave, but the bandwidth is wider. You're probably better off just using the Z-Wave dongle and like Wireshark or something like that. But
Ah, gotcha.
I'm sure you could capture it, but I forget how wide the bandwidth is on Z-Wave, but the bandwidth on these is like 10 kilohertz or something, maybe 30 kilohertz. You're looking in the megahertz range for the bandwidth on Z-Wave probably.
And what was the driver for figuring all this crap out? Like, why did you do this?
So I had a friend that bought this and he wanted to use it and get it into his home automation setup. And I said, "Oh, send me your sensor. I'll decode it for you." So that's why I did it.
Just like that, like it's nothing.
Yeah.
Like,
Definitely
yeah, sure.
wasn't nothing. I almost got to the point where I was going to give up until I saw that stupid way they were encoding the temperature, where it was just, if you looked at it, it was like, wow, it's right there in my face. But
That's like a classic CTF thing too. Like just banging your head against the wall, trying all this overcomplicated stuff, and the answer is just like,
it's in the clear text string right there. It just
Right,
says
yeah.
temperature equals 10.
yeah.
like.
But if I actually had the base station, it would have been a lot easier to decode. So I would have actually known what data it was sending.
So this thing is intended to talk back to a base station. You probably covered this in the thing, and I was busy trying to do stream things.
Yeah, it's for like it's part of a weather station.
Oh, that's cool. That's cool. Looks like a meat thermometer.
I mean, it could be.
I guess you could
be.
use it as a meat thermometer if you wanted to.
Nice, a wireless meat thermometer that would melt as soon as you put it in the oven.
It's a feature. It's a feature.
It's a feature, right? When the thermometer melts, you're
done.
a little below done, because I'm thinking plastic melts sooner than a turkey's cooked.
But you'd at least have humidity.
You know the humidity inside your oven.
I mean, we deep fry our turkeys, so I guess that would be fine for that, right?
Yeah, as long as you don't put the plastic end in.
All right. Anybody else got anything? Otherwise, we'll move on to Nate.
Yeah, there's nothing came in on the chat, so
Cool.
stream chat.
Yeah, 'cause I confused everybody.
Dan, stop sharing your screen.
Totally. Yeah, if you stop sharing, oh, now everyone can see the Zoom stream, so everyone just bear that in mind. Turn off your video. Oh, no one has their video on. It's good.
I have my video on.
Well, yeah, you do on the Enterprise. And Dan,
Come
This is
get me,
the one.
Nintendo.
cool. Come get me.
It's not the Enterprise. It's the Intrepid. It's a
Oh,
Intrepid
jeez.
class.
Mr.
It's the Voyager.
Yes. This is Voyager, and that's Pete coming all the way from Australia because,
Still not upside down, though.
well, his video's off right now.
Try to work. It's hard to work over upside down, man. Try it.
All right, so my talk is less of a talk. Oh, there we go. Now Dan's upside down. If we're all maybe we're all the ones that are upside down.
Well, you know, that's how
Pete.
it is.
And Pete is right side up.
Australia's on the right end of the world. Yes. Bottom end. Yeah, you know.
All right. Well, anyway. Right, so my talk is less of a talk and more of a, I got a 3D printer at Christmas time. And let me switch so people can see me talking here. Now they can't see any of you, they can see me. That's what's important, right?
Yeah, we don't matter. Go.
You don't matter. Right, so around Christmas time, so, I mean, the full story goes, my daughter, who's 10, for whatever reason, like 6 months ago, comes to me and says, I want a 3D printer for Christmas. Now, I don't know what she thought she was getting into, where she even heard about 3D printers, but she wanted a 3D printer. I think she was picturing, like, something more like a toaster, where you, like, hit a button and toys come out. But yeah, not quite how a 3D printer works. But you know, I've wanted a 3D printer forever, and if this helps fuel her like creative side, then absolutely. I want a 3D printer. She wants a 3D printer. Again, I don't think she quite expected what she was getting into. But now we have a 3D printer. I picked up an Ender 5 Pro for Christmas, and it's been pretty much printing nonstop since. Which, from what I hear from other people who own 3D printers, that's just kind of the way it goes, right? You've got a 3D printer, you're always printing something. So basically, I just thought I'd talk about like kind of my first impressions. How hard was it to get this thing set up and running? I know some 3D printers are harder than others to get up and running. Some require like a lot of even like precise measurement and whatnot to make sure the bed's at the right place, and you know the print head is in the right place and all the pieces are where they need to be. The Ender 5 Pro was not like that. The Ender 5 Pro has this cool like it's basically got a box frame, and the head is at the top and the bed moves up to the head, right? Which is not the way some printers work. Some printers move the head up and down to get down to the bed, and they print upward. You know, this one doesn't. The bed moves up and down. And from what I'm hearing from other people who have set up other printers, again, this is the first printer I've ever had any direct contact with. It's like dirt simple to get set up because the frame is like self-writing, right? You basically bolt it together and it's already got all the right measurements. So that it took me like half an hour to get it set up. I did run into a problem when I first set it up where the heated bed didn't work. I turned it on and like the screen just flashed at me, and I did some Googling and I found some people that are like, oh, check the resistance on the heated bed, and if it's below X, your bed's probably shorted. So I did that, and it showed that the bed was shorted. Turned out I measured it wrong, because, you know, that's the way it always works for me. I try to do something simple to troubleshoot, do it wrong, and then spend 2 weeks going down the rabbit hole based on something you measured wrong. Turned out the heated bed was fine, but on the back of the power supply is the damn international switch, you know, for 220 versus 110. It was freaking switched to 220, and that was the whole problem. I switched it back after I figured that out, and everything works perfectly now. So, you know, laugh at Nate, whatever. But now the whole thing works properly. I bought a second heated bed trying to troubleshoot the problem, so now I have a spare heated bed in case I ever actually have a problem. But anyway, that was really the only problem I had setting it up. Otherwise, the thing worked perfectly out of the box. Some of the folks here at DefCon 610 gave me some hints when the bed was not working properly about how to get things to adhere properly to the bed, and that was like stick blue tape down. As dumb as that sounds, blue painter tape. Put down the tape and clean it good with alcohol, and then your builds, I mean, things stuck to that blue tape better than they should have. Like, they were difficult to remove. Every time I took anything off of that bed, I had to basically rip off all the tape and put new tape down, which was kind of a pain in the butt. The minute I got the heated bed working, however, the blue tape was not only not necessary anymore, actually couldn't be used, because when the heated bed heated up, it like melted the adhesive on the tape, and the tape would peel up, so couldn't use it anymore. Luckily, though, the heated bed solved the adhesion problem I was having without the heat working. So, that was that. So, to anyone out there who's not familiar with 3D printing, I don't know. I feel like I'm one of the last people to get on this train. A lot, like, 3D printers have been around for, I don't know what, 8 years or so. I remember that I first hearing about the first 3D printers that were in the consumer space. So, I'm not exactly new to all, or I'm not at the head of this pack. But anyone who hasn't bought one yet, if you're expecting something like my daughter was, where you basically just like handed a file and out comes a thing, there's a lot more to it than that. There's a lot of learning that has to be done. One of the biggest things that people, I don't think, really realize without having talked to someone who's already done 3D printing is that printing stuff in a 3D space, it prints layer by layer, right? So it starts at the bottom and it goes layer by layer up, and it builds layer by layer by layer. And as soon as you have anything that sort of plumes outward, right? Now there's nothing to support that, right? So I guess an example would be, I don't know, you're printing, well, just anything that has an overhang, right? You're printing a box or a right angle, right? It goes up and then over. Well, the over won't print because it can't, there's nothing to print on. So it builds supports up to do that. And supports, I have found, are both a blessing and a curse, because when you print something that's small and intricate, like this little guy, if you guys can see this, I printed a little minifig. This is one of the things I was really hoping I'd be able to do with the 3D printer. It was a nightmare to get the supports out of that thing, because like in between this figure's legs and in the bow there that you guys can hopefully see, and like under the arrow and everything, there were all supports underneath all that. There's different types of supports. There's all kinds of configuration options you can put into these supports so that, they, adhere differently to the model, or how thick are they? How are they filled inside? What type of support is it? The core difference are there's like these standard supports that are basically just straight up lines that come from the base up to the bottom of the print. And there's tree supports. And I used tree supports on these figures, and that worked really well until it didn't. There's a couple things that the tree supports just would not support well, so I had to go back to standard supports. They're a nightmare to clean out, but the tree supports are easy to clean. It's just, there's all kinds of crap to learn. I spent like half an hour last night just reading about how to do different supports on, models, and that's how I was able to get this printed, right? So with the bow and everything. I have this other figure that is this dwarf, and you see how his one arm is kind of out to the side? That was a nightmare to get to print. I have a dozen prints that look like this. If you can see him, he's missing an arm. Got like a dozen of these in my garbage can right now, because I was trying thing after thing after thing to try to get that arm to print, and I ended up having to switch the type of supports. I found a guy who prints minifigs and does YouTube videos about it, and he actually had settings for, he had exported his settings and put them up on the internet for people to grab and download. I can probably look that up and put it, share the link somewhere if people are interested in that. Which actually brings me to a next, sort of the next thing, right? So you don't just take a 3D model and throw it at your printer. You have to sort of tweak it, and you have to do what's called slicing. What slicing does is it takes a 3D model and it cuts it into slices, and that's the instructions that are fed to your printer. It's not like an inkjet printer where you just take a document on your page or on your screen and hit print and it goes off to your printer and out comes a document. You actually have to tweak these things and try to position them in such a way that they will they stand a good chance of printing. And give me just a second here. I'm going to share a screen. Hopefully you can still hear me and everything. That didn't break anything. So this is Cura, Ultimaker Cura. I think Ultimaker is the company that made the MakerBot. Anybody in the Zoom that can hear me and wants to correct me, go right ahead. So they've been in this game a while. The MakerBot is one of the earlier printers that I ever remember hearing about. But Ultimaker is basically, it gives you this 3D space here that you can take your model and throw it in there, right? So here's a good example of those supports I was talking about. See underneath here, there's just dead space, right? You need supports to print that up. This is a set of brackets that I'm printing for a friend so he can mount his Xbox 360 on his wall, right? So, or Xbox One? Xbox One, sorry, I'm too many gaming consoles running through my head. So these are actually currently printing on my printer. I'll show you that in a minute. But basically, once you've positioned the thing, this is a representation of the actual build plate on the Ender 5. When you set up Cura, you tell it how big the build plate is. You tell it how much space vertically, the Z-axis here, your printer is able to print. And then it gives you this space so you can set up your print, right? And so I've placed these things. Of course, you can move them around or whatever, but I don't want to do that right now because then I'll have to reslice it. Down here, if you can read that on the stream, it gives you an estimate of what Cura thinks it's going to take for you to actually print this, right? So that way you can do things like judge, do I have enough filament on the spool for my printer? Do I have enough time for this thing to print? How much, whatever, how long is this going to take? This is an estimate. I've seen this vary wildly from actual print, right? But it's a good sort of rule of thumb. I'll show you something else that gives you an estimate once I show you what I'm using to control my printer, which is another topic I'm going to touch on. So, right, as I was saying, there's a ton of different settings here that you can do to control how this thing prints. And one of those things, as I talked about, was supports. Once you've told it what kind of supports you want it to build and whatnot, and then you slice it, that all goes into the instruction set, and then you can actually preview it here in Cura. So now you see what the print should look like when it's done, right? And you see these empty spaces here are now filled with, are now filled with support material, right? So that'll print, and you see how, I don't know how well this comes through on the stream, guys, but there's this spot here where there's like an easily breakable filament, right? Well, that is basically there to make it easy to break away the supports later, right? And sometimes that's easy. On these, I printed these once before, and then he accidentally broke them. So that's why I'm printing another copy. But these were surprisingly easy because it's just this big block, right? It just basically broke off, and then the support was out of the way. So that's the way it could work. I don't think I have a picture. Hold on, let's see here. I gotta start a new one if I'm gonna do that. Well, whatever. I was gonna show you one of these minifigs, how crazy the supports look when you set up the supports for one of these minifigures. Because basically the entire figure is just covered in plastic. And then you have to pick all that out later, which is a real pain in the butt. So, let me go back here. Now you can see me again. I'm also gonna... Sorry, doing a little bit of live editing for the stream here because I didn't like the way that looked. Okay, so, right, so the other question you might have is where the heck do you get these 3D models? Well, there's a couple things you can do. One, you can make your own, which is, like, if you're good at that sort of stuff, is not that bad to do, not that difficult. But if you don't know how to do that, if you don't know how to make 3D models, Thingiverse is a website that basically has, I don't know how many thousands or millions of models up there. Basically, anytime anybody makes anything, they can upload it to Thingiverse, and then you can go download it for free. That's where these Xbox 360 wall mounts came from. That's where I have this little Baby Yoda that Disney, please don't sue me, that I printed out and my wife painted, right? This came out as all white PLA filament, and she painted it. It's a Christmas ornament. We're going to hang it on our tree next year. That came off Thingiverse. Do I have anything else handy? I don't think so. Oh! A friend asked me to print this because he's going to give it to a buddy of his for a present. If you can see that, it's the Teenage Mutant Ninja Turtles on a New York City sewer lid that I printed out for him. He's going to paint it up and give it as a gift. I mean, the versatility, right? The things I've figured out that I can do with now that I have a 3D printer is pretty crazy. And this actually leads into a great segue to if you want to build your own models, right? Now, I'm not good at 3D modeling. It's a thing that I've just picked up now that I'm doing the printer. But I'll make a long story short. We have a front-loading washing machine. Anyone who has a front-loading washing machine knows they shake like hell, right? When you put in the laundry and whatever, and they run. I got these rubber feet for underneath the washing machine to keep it from shaking. The problem is it vibrates just enough that it walks off the feet sometimes. So what I'm doing, and I just printed these recently. Hold on, let me go back to my share here. I made these cylinders. Really simple. It's just a circle with another circle inside of it that I've extruded to a couple millimeters. And I'm going to glue these things on top of these rubber pads that I have to keep the feet of the washing machine on the pad, right? I haven't done it yet. But this is the sort of thing where when you don't have a 3D printer, yes, I could have done this by getting, I don't know, a piece of metal and drilling a hole through it and sticking that on top. Or getting a cardboard tube that's thick enough and cutting it down and putting that on there. Like, all those things could work. But now what I could do is, I can make this any shape I want, any size I want. I don't have to go out to the hardware store and hope I can find a tube that's just the right size, or a piece of pipe or whatever. I can just print it, right? And off I go. Now, that's a slippery slope, right? Because you could be like, oh, I can just print anything. And then you end up spending hours and hours in research and development trying to print something you could have went out to the store and paid $10 for, right? So, slippery slope. Unless you really enjoy doing that, which I'm always, I'm a big proponent of. If it costs a lot to do it, but you had fun doing it, like in time or, whatever invested, then it wasn't a sunk cost. It wasn't a waste of your time. You enjoyed it. You got enjoyment out of it. So whatever. If you really enjoy building things like feet for your washer, like I did here, then, more power to you. So this program I'm showing you here is Autodesk Fusion 360. I don't know that it's the best out there. I know that if you're not using it for commercial purposes, you can use it for free. I don't know if that's a limited time or not, but when I went, it was recommended to me by somebody. I looked it up and it said, here, if you're not using it for professional, you can use it for free. So here I am using it. If that ever dies, then, I'll have to find something else or find someone that can give me a license, because I hear this is not cheap software. But anyway, so it is a little tricky to use. I had to do some research basically just on how to make this simple shape, unless you're familiar with how these things work to begin with. I did some 3D modeling stuff a long, long time ago, just as a fun little thing I was tinkering with. So some of that's coming back to me, but we're talking 15 years ago. That's how long ago I was doing this with, what was the name of that? Moya, was it? Moya. Yeah, I think that's what it was. Anyway, long time ago. All right, so I'm rambling quite a bit here. Going... All right, so far along, anybody from the DefCon group, you got any comments you want to throw in here? Any commentary about the things I'm doing here? What do you guys do? Like, what do you guys build 3D models in? What do you slice in? Do you use a different app? Commentary, then there's one more thing I want to show you guys. And if you're going to talk about that Raspberry Pi thing, don't, because that's the next thing I want to talk about.
Oh, yeah. You got to talk about that. That's like the life changer for 3D printing.
Yeah. So hold on, I'll switch. Here, I'll just do that quick, and then we can have a conversation. All right, so if, let's get this out of the way. Make this a little bigger. No, I want to make it bigger, not scroll it. There we go. All right, so the other thing with my printer, now some people, they set up the 3D printer like right there, just right next to their desk. They just let it print, right? And it's right there, you can watch it. That's a big deal. To be able to see your 3D printer, in my opinion, after having worked with it only for a couple weeks now, being able to see what it's doing is really valuable, because it's really easy to throw a print at something or throw a print at your printer and something goes wrong. Just the simplest little thing ruins the whole print. And if you're not watching it, it's just going to waste a whole bunch of filament, right? And that's generally not how you want to spend your day, right? It takes 16 hours to print a thing. You find out that on layer number 7, something went wrong, or it didn't adhere to the build plate properly. You come down to just a pile of squiggles of PLA. So what you can do is there's this cool little project called Octoprint, right, Octoprint is the software project. There is an image for Raspberry Pi called Octopi, which you basically just image, right to an SD card, pop into a Raspberry Pi. You plug the USB port of your Raspberry Pi into the, hopefully, USB port on your printer. I don't know if that applies to all printers, but the Ender 5 has a USB port I just plugged right into. And then you connect the thing to your network. You can even connect a webcam to it to watch the print. And basically, I can now manage my printer right from here. Now, obviously, between prints, like I said, it's not like an inkjet where you can just send job after job to it. Between prints, you have to re-prep the mat. You have to take the print off, whatever you printed off. You got to clean the mat. So it's not like completely hands-off at this point. But this takes the dozen trips to the other room to look at your printer down to just monitoring it via a webcam. So this is the thing you're seeing here is the Octopi or Octoprint interface. I have a couple plugins added. There's so many things you can add to it via plugins that it's just crazy. So this is a plugin I found, which is basically a dashboard. If you haven't figured it out, there's a print running. That's the one I was telling you about. My buddy's brackets that he wanted. Here's a nice little graph that shows you basically the temperature. This is out of the box, the default page. I don't know why the temperature monitor is the default page, but it is. This dashboard is meant to replace that and give you a little more to look at and a little more useful stuff here. When I want to make a new print, after I've taken the model and sliced it in Cura, I can just upload it right here. Once it's uploaded, I just tell it to print, and as long as it's connected to my printer and the printer is ready to print, like I said, you have to prep it before you start printing, it'll just start printing. You'll see these gauges, it'll heat up the build plate, it'll heat up the head, and then it'll start printing. And you can watch the whole thing right here. Now this is just a Raspberry Pi camera. So you can see here it's printing that lower section where you can see that little zigzaggy stuff there. That's the support I was talking about. I started this print maybe an hour before our meetup, and looking at it here, I can almost tell you that it looks like maybe there's something off with the temperature because there's some little like pox marks on the print, so that's unfortunate. For wall mounts, I'm not going to care as long as they're structurally sound. I can just sand those off later, so I'm just going to let it go. But this is basically, Octoprint in action. The really cool thing, and I have this turned off at the moment because there's really no reason, it just adds time between your prints, but you can do a time-lapse video of your print, right? Which is fun for two things. One, if you had a print that ran a long time and you want to see where it failed, you can go back and look at the time-lapse, or you just get a really cool video to watch later, right? So if you printed this really cool elaborate thing, you can then have the time-lapse as something that you can share with people to say, like, look at this cool thing I did. And they do look really cool. So that's kind of Octoprint in a nutshell. This thing, if you don't have it and you're running to your basement to deal with your printer like I am, this changes your life, right? I know, Eric, you're the one who put me onto this because you do the same thing. You've got your printer in the basement, right? So if I can be up here in my office working and watching my print go, and that's pretty cool. So
Octoprint's a game changer for 3D printers. Plus, it stores your prints. So if you had a successful print and you want to print that thing again, you just hit go.
Yep.
You don't have to like load it and transfer it and all that crap.
So I'm going to switch back.
You don't tie your machine up either.
Yeah, I'm going to switch back to the Zoom session here. So anyone who doesn't want to show your video, stop turning. There we go. All right. So yeah, I mean, discuss, right? So what have you guys done that I didn't cover? Did I get anything wrong? Whatever.
I think the biggest thing with 3D printing is I printed a bunch of crap, the kids, toys for the kid and all that stuff and whatever. But the biggest thing is when you have that moment where you're like, I needed a weird washer size for my refrigerator. I couldn't find it anywhere. Nobody had a hardware store. I tried a bunch of shit. Nothing worked. And I just 3D printed it just like you did for your washer. And it was like, holy shit, this thing is awesome.
Yeah, I can just do these things now.
Yeah. And for me, we're all Linux at my house. So for slicing, I use Slicer, SLIC3R.
Of
And
course.
it's got a direct, there's a button on it. Once you've sliced your thing and you've got it all set up, you just hit the button and it sends it directly to the Octopi.
Oh, that's cool.
Yeah, which is great.
I don't know if Kira has that or not. Kira does have the ability to send the slice to a printer if you've got the printer like on the network. I don't know if it'll do it to Octopi. I'll have to look into that. It might.
Yeah, it may. And then what's the other thing? For quick, dirty, easy stuff, I just use Tinkercad, which is very feature filled, but it's kind of aimed more at students and kids and stuff. It's not like Play School My First CAD, but it's easy to throw something together quick with.
Mm-hmm.
So that, and then of course Thingiverse all day long, and I did a lot with the trying to get the bed sticking happening, and then it ended up to be that magic PEI plastic.
Yeah.
That stuff is just, it's some kind of voodoo, I swear to God. Things stick like glue while the printer is on and printing, and then as soon as it comes to room temperature, they just pop right off. It's nuts. Bananas.
Pretty cool.
It's
So
voodoo.
here, so this is a quick share of Thingiverse. I mean, there are pages and pages and pages of just random things that people have come up with and put up on Thingiverse. Like, this guy appears to have printed a flute. You want to print a flute?
Wow.
That's pretty crazy.
God, it's nuts. And like if you're thinking about a 3D printer, just go to Thingiverse and just scroll.
Yeah.
And probably after about 20 minutes, you'll be like,
Oh.
I gotta get one.
I will have to get the link and put it in the notes or whatever and get it to you guys. A friend of mine sent me a link to a page. You ever hear of a lithophane? It's a big word, but imagine like a piece of tracing paper or whatever where a thing has been etched into it, right? And then you shine light through it and you see it. You can make things like that on your 3D printer.
Yep.
So basically, this is a site where you upload an image, and it'll take the image and it'll put it into a lithophane for you, and then it'll give you an STL, and then you can just slice it and print it on your printer. And they look terrible when you pull them off the printer. You're like, man, this looks like it's totally wrong. How is this? And then you hold it up to the light, and it is a perfect image. Like if you were to take it and grayscale it, right? I have one printed, but I don't have it handy, so I can't show it to you right now. But yeah, it's awesome. It's pretty amazing. So like
I just discovered the website. I know what I'm printing tomorrow. Wow.
Are you looking at the lithophanes?
Yeah, they're insane. And these
Hang
are
on,
like normal people printing, not like some fancy stuff.
Oh yeah. It's just hang on, I saved the URL. Let me find it here and I'll share it quick.
Lithophanemaker.com?
Is that what it is?
I don't know.
That may not be the one that I used, but where I have it in my Google Keep here somewhere. Guess I gotta search. I got too much stuff in here.
Dan, what about you? I know you're a big 3D printer.
Yes, it is. It is indeed lithophanemaker.com.
Yeah, well, the most recent stuff I printed was all the PPE stuff, like 700 things for face masks. But
oh right,
I can't think of anything off the top of my head. But it's like, oh, I need this thing for this fix this. You can make it or find stuff that people have done. I'm trying to think of the most useful thing I've printed.
I mean, you see these pictures
a knob
on this
for a washing machine I designed because it broke.
Nice.
That's
actually a good example. So my dad repairs old radios, like not old radios, but like those old Philco, the wooden cased stand up radios. It's just a hobby of his, right? And he probably got like 24 of them in his house right now. And he's got a friend within the community. There's a community of people that do this because it's just that big of a hobby. There's a guy who 3D prints things like knobs, right? Because you can't get them anymore. It's not like you can just go out to a 3D or go out to a Philco repair place and buy a knob. They're getting scarce. So this guy actually invested in a scanner that he can scan an existing knob that he has, and then he can take that and print out more, right? Obviously they don't look authentic anymore, but you can doctor them up and make them look authentic. In a world where you can't get authentic knobs anymore, it's good enough, right? So that's another great use for 3D printers. You mentioned your knob thing, and that reminded me of that.
My
Yeah.
brother's got a business where he's building mounts for engines for like canoes and stuff, kayaks. And he's got like it's not 3D, but it's like a 2D router-ish thing. It's similar sort of design that he basically makes these mounts for each individual client. So yeah,
That's cool.
it's pretty awesome.
Actually, now I remember the most useful thing I've printed. I printed parts to build a CNC. That also runs Marlin and Octoprint.
Nice.
Yeah,
Yeah,
mostly
Dan's
printed
got a-
CNC. So
Dan's got a CNC router that'll do 4x8 sheet, right?
yep.
That's
The only
awesome.
thing is it doesn't go all the way to the edge on the 4-foot side, so I only get about 46 inches. I didn't make the table wide enough, but yeah, I cut a giant snowman out with it. It
Well,
was
then
pretty
it's
cool.
totally lame. You don't get a full 48 inches? Forget it.
I can fix it. I'm just too lazy.
No, but that's another great thing, right? So shortly after I set up the Ender 5, as you do, I was just tinkering around on YouTube looking at other people that have Ender 5 setups. And I found this video where this guy's like, yeah, he's been doing it forever, right? He's been through like several different versions of the different Ender models. And he's like, I'm setting up an Ender 5, and here's all the stuff that I did to it. And 90% of the stuff that he did to it is just stuff he downloaded from Thingiverse and bolted onto the thing. So it's like the heated bed I was talking about, right? There's just a cable soldered onto it, right? And then the bed moves, like I mentioned, right? Some 3D printers, the bed doesn't move. Well, this one does. Well, anyone who knows what happens when you've got a solder joint that flexes, eventually that's going to fail. Somebody made a support for the cable so that you basically clip it onto the bottom of the build plate and it holds the cable up so that it moves the stretch point out to the cable part instead of the solder joint, where really it would be a lot more resilient to that kind of thing. So I printed one of those out and put it on.
I have a ANET A8, and the bed moves on that one. The bed moves forward and backwards, and sure enough, the heated bed cable is gone to shit. So yeah, I was most of the way through a really massively large print, and it came unstuck because the heat from the bed stopped. Which actually reminds me, so there's some guys working with the Octoprint thing, and some I don't want to use machine learning, but I think that's what they're doing, where it'll look at the images that the Octopi takes, and it'll look for spaghetti.
Oh, Spaghetti Detective.
What is it?
Spaghetti Detective.
Yes,
That's the
and if it
plugin.
sees spaghetti, it'll stop your print.
Oh, wow. That's cool.
Yeah, so you can like hit print and then go to the office, which I know is a really weird thing to say.
Go to the
but you
what?
hit print, and then if it F's up, it'll stop the printer for you. So that's something to look at too once you're done being obsessed with watching your printer print, which I'm pretty sure lasts for a couple of years.
You should also have a smoke alarm really close to it or near it, just in case it decides to catch on fire.
Yeah, so that is a valid point. Octoprint, and there was another tool that I was using that as soon as you open it, it's like, by the way, don't leave your printer unattended because it could catch fire. There's a lot of heat involved, right? So there's the heated bed, and then there's of course the nozzle that it actually heats up the material, and that gets pretty dang hot. It's like up to 215 degrees Celsius, which is really hot. Fahrenheit.
Also, the connections to the control board, if they're loose, you could get arcing there. Well, maybe not arcing, but a loose connection would heat up and you could catch the board on fire there too.
That's a bad thing.
And some of the Chinese-made printers, like my ANET A8, the board is just not well engineered. So, I'm fairly certain that thing will catch on fire one day, and I'll have to get a replacement board for it. But the reason
sorry, go ahead.
The reason I chose this printer is because it's a knockoff of the what is it a knockoff of, Dan? Just blanked.
Was it the CR6 or whatever, the Creality or whatever?
Didn't you say it was the Pursa?
Knockoff, yeah.
Yeah, it's a Persa knockoff. So there are nothing but endless, because it's one of the most popular printers ever made. There's endless upgrades, replacements, and all this crap for it. So I'm like, I'm going to buy this $180 printer, and then as things fail, I can just swap in, new parts and all that. So, Dan, what were you going to say?
Yeah, the SKR is a popular board that people replace stuff with. They're fairly inexpensive, and they replace the drivers on. The board itself is probably like 30 or 40 bucks, and then the drivers are, a couple bucks each for the motors. But and it's a 32-bit board. Everyone's going to 32-bit now on printers instead of like old 8-bit. Like mine's an 8-bit board on mine.
Apparently
I don't think it really matters because it's not doing that much. It's just being told to move X, Y, and Z. But
yeah. Apparently the 5 Pro is when they had the cutoff. Creality had the cutoff where they're all 32-bit. If you buy a 3, it comes with a 32-bit board now, but I guess they originally shipped with an 8-bit board. But the 5 is 32. Maybe there were versions of the 5 that was 8-bit, but I think they were all 32-bit.
Something else you could look at, Nate, I just thought of with those bumps, your layer height might be off.
That could be it.
Your layer
because
height might be
these-
less, and then it's extruding too much.
These
so.
minis, some of the first ones I printed, because I didn't know much about layer heights and whatever, I just in Cura it's got settings for high quality and standard quality and whatever, and the high quality is like a 0.12 millimeter depth, and that's what I first printed these things on, and they were a little bumpy, right? And I think one of you guys told me that you thought it was the temperature that I was
Yeah, it was me.
that I was printing at. And I tried fiddling with the temperature, and that didn't seem to help. But these settings that I found online go down to a 0.08 millimeter layer thickness, and they came out pretty damn nice. I mean,
there's some math you can do what your minimum and maximum layer height can be. I forget. It has to do with the nozzle width. And,
Okay. I
Yeah.
did.
And the steps on your steppers, so you don't do like a 0.15 might not work because you're like halfway between a step and the
Yeah,
step motor's
right.
not
So
gonna do that.
I Googled the Ender 5, and apparently that number is 0.04. Is like the absolute minimum. However, I tried doing some prints at 0.04, and I think this one actually was done at 0.04. So you can see it did. Well, you can't see me. Here, I'll switch my camera for a sec.
Yeah, I usually do 0.2.
The YouTubes and whatnot won't be able to see you guys anymore, but that's okay. But this one, I printed at 0.04 just to see what would happen, and it printed. But if you look at, so this is one of them that I've used in tree supports on, and that was one of the problems, right? But if you look at it compared to the one that printed nicely, maybe you can't see in the video, but like the base on the one I printed at 0.04 is a little weird. Like the supports under the base are stringy, so I don't know if maybe 0.04 is not an okay place to print at. But
I don't think I've ever heard anyone print at that before.
Yeah, well, I just whatever. I'm learning. I want to try it, right?
No, yeah, that's good because I usually just stick to 0.2. I don't do anything that intricate, but
so 0.08 on this guy did. The print I was just showing you is at 0.2, I think, because that's the standard quality on Cura.
Yeah, there's there are calibration things you can print where it's like a cube and the dimensions of the cube should be perfect. So you use a caliper to see, if running the dimensions correctly and all that stuff.
Yeah, I have one of those. In fact, that was probably the first thing I printed because it was so like I went through and I did all the setup that came from Creality, and then now I'm like, okay, now what? And the thing I found was like, okay, go get Cura. That's why I'm using Cura, because it was the first thing that was recommended to me. And go get this model and print it. And it was that. It's one of those calibration cubes.
Yep. Yeah, I did that. I
yeah.
did some temperature cubes, some overhang things, just a bunch of calibration prints. And that really helped accelerate everything. And now it's to a point where I have to do some minor temperature adjustments if I change filament colors, because certain colors are like other temperatures better than others.
Yeah. Yeah.
And one thing I like about my printer is it has auto leveling. It's a magnetic sensor, but I know a lot of the other ones have like a BL touch where it's a physical sensor, a touch sensor. But
that's
I don't know. I really like auto leveling because you get it close and then you let the auto leveler, and then Marlin does the math at the board. The bed's off by a little bit. It'll adjust the G code on the fly within the microprocessor to print level. But
that's kind of cool. I've had one or two cases where I didn't have the bed just right. and it really messes the print up on the first couple layers. Really.
A bad hack that I do sometimes is I print at 200% width, so it it extrudes twice the width of the head, and it makes it stick really nice. But that's
Mm,
not the right way to do it, but sometimes works for me.
you know, whatever works, right?
Oh, on the initial layer, you change the percentage.
Yeah, the 200%, and stuff sticks like glue.
Yeah, I've done that on a couple things, especially when I was tinkering with these minis. I ended up just using rafts, and that seems to do the trick because the minis are a little tough to, especially when I was doing tree supports. Tree supports do not stick well to the build plate at all because they're so freaking thin.
I've never used one. That's something that's newish. I came over from Slicer to Cura. Now I'm
Yeah.
actually looking at going to Prusa Slicer, which is based on Slicer.
Okay.
But-
I mean, I'm absolutely open to other suggestions if you find that there's one that works better than Cura. Cura's been
Problem is
working
you
okay for me.
You have to port all your settings over. That's the pain, and they might be called something slightly different in a different slicer.
Yeah, well, I don't have a ton of settings yet except for those ones I imported. So if I'm gonna switch, now's the time.
I like Cura. I used to use Repair Host or whatever,
Mhm.
some Java-based application that basically would just call Slicer anyway. But
Apparently,
everyone seems to be talking about Prusa Slicer now. But
apparently Octoprint has a built-in slicer. Does any? I've never.
Yeah, it's got a plugin called Slicer, and I mean, I tried it when I first got the printer, and I haven't touched it since, so I'm sure it's improved. But the general idea is, you get your printer settings into that, and you literally just dump the STL file right into Octopi, and it just slices it and prints it.
Does
yeah, it just doesn't sound like a good idea.
yeah?
to
How does
me.
it handle the supports and stuff? Because I find that on more complicated stuff.
Yeah, I think it's more for simple stuff. Like,
Oh, okay. So you have something that doesn't need supports or whatever, you can just throw it in there and go.
yeah.
Okay.
I mean, supports, and that's something I was going to ask you, Nate. Have you ever thought about maybe just drawing catting your own supports into things?
I mean, theoretically, I could do that.
'Cause,
I'm not good enough at CAD yet.
Right. Like taking your example of your minifig, like you don't need supports between the legs, but if you tell the slicing program to do supports,
It
it's
does
going to
them,
put
yeah.
tree supports there. You know, you only need tree supports over the arm. So,
Yeah.
I
Yep.
think it might be easier to draw your own.
Yeah, yeah, and maybe the guy I found, well, the place that did these examples, he's like, I never use tree supports. I used to use them, but I hate them now, and he doesn't, he's like sworn them off. I found honestly on the prints that it worked on, tree supports were so much easier to deal with. They were so much easier to clean out. They were so much easier to just work with in general. And I wish they would work on these little minifigs because cleaning out this archer I was showing you, I mean, her whole body was basically encased. I had to pick everything.
You should have just 3D printed a block of
I
plastic.
should have and just carved it by hand with an X-Acto knife. That's about the amount of work I had to put in. Now, it took me like an hour to clear it, right? So that might not sound like a lot, but for a minifig, right? I mean, it's to the point where I'm like, I got the STL for this from Hero Forge. We designed it on Hero Forge, and then you can pay Hero Forge to print it, or you can you can get the STL file and print it yourself. I may just pay to print them from now on because it was that much work, right? I mean, it took me several tries to get these things to print, and then when I finally got it to print, I ended up breaking a few pieces on the thing trying to clear the damn supports. So it's like
They're probably printing with dual extruders and a water-soluble
maybe
Yeah.
whatever to
could be
'cause I know
whatever
some people
they're
do that. Yeah.
whatever they're doing. It's freaking awesome because the one I've got that was printed, right? The one they printed and sent to me looks awesome. I mean, it's like amazing. They do full color prints. I think we were talking about that in the Zoom before I started doing this. But they'll print it full color. In fact, let me grab it again. Hold on. See if I can knock everything over on my shelves again. Where did it go? I tossed it back in here after I showed it to you guys, and now I don't know where it went. So, but yeah, you can design a minifig on Hero Forge. So if you do like tabletop gaming, you'll know why you'd want minifigs. Where the hell did it go? I have too many minifigs in here is the problem. I should have left it out on my desk. But if you want minifigs, you know, to represent your characters, you usually just go to a game store and you buy a generic minifig that kind of fits what you want it to look like, and off you go. And I don't know where the hell it went. Well, whatever. It's not important. I'll find it the minute I'm done streaming. So what these do is Hero Forge has a whole online. It's like a character creator, like you would use for an RPG.
Yeah, I'm on it now. It's insane.
Yeah, you pick the face, you pick what weapon it's holding, you pick the race, you pick, you know, like the clothing, and
Mount.
yeah, you can have it riding a tiger or whatever, right? Like the one we printed was a Christmas gift for my daughter because we recently started playing D&D together. It's her first time really playing D&D, and we printed one out for her character for Christmas because we thought it would be fun. And she loves cats, so we put a cat on the plate that the character stands on, just because we thought she'd like it, right? And recently they added this feature where you can then color it in their builder, and then it'll print in color, which is like boggles the mind, right? How the hell do they print in color? But I mean, they print these things out. They are beautiful, like as nice as this figure that I was holding up looks, which for I think an at-home print is actually pretty darn good. These things are just perfect. They look like the same thing you'd go buy in a game store, and those are usually hand painted, the ones you get at a game store. So, or you
Maybe
get them
that's
blank,
what's really
right?
going on. They're hand painting on the nippers.
That must be it. No, it does. They don't look hand painted. It looks like colored plastic. It's amazing. It's just amazing. I don't know how they're doing it. I'll have to look into it someday and see how they're doing it.
Magic.
Magic. Yeah, they print it out in a solid color, then they go done,
Yep.
and it's colored.
Back.
Total magic. But yeah, they're pretty awesome.
Yeah, you could use them for, like, you could pay for the ones that are in weird poses that you can't print, which seems to be most of them. And then, you know, for ones you can print, you just go ahead and print it yourself.
Yeah, right. So definitely I could do that. It's like, I think it was like $8 to buy the STL instead of buying a minifig, and it's like $20 to buy the figure printed black and white or printed without color.
Right.
So it's not a huge price, and that's honestly, if you go to a game store and buy a minifig, you can pay $20 for a minifig that's painted, you know. And if you're set up to paint them at home, it's not that big a deal. You get a custom minifig and whatever. So I wouldn't recommend using them to buy every little kobold that you put down on your gaming mat because it's going to cost you a fortune. But for your characters, right? For something special, you know, you're starting up in a new campaign, you want a custom character, you know, it's cool.
How much did you spend on minifigs? Well, we wanted to do a whole army of kobolds.
Yeah, right. So we spent $6,000 printing out kobolds. Yeah, that'd be a bad way to go. That. But yeah, the color print is like $50, which is I think a lot of money for for a minifig.
Yeah.
So.
All right, I can't think of anything else. Anyone else got any 3D printer crap? That's
or horror stories or anything?
I was gonna ask a question.
Sure.
I don't play this game, but I don't know if you guys play Warhammer. I wasn't sure if you had an idea to make your own Warhammer set, like custom figurines, or just probably can get away with printing out a bunch of Warhammer figures. And I don't know how.
There are Warhammer figures on Thingiverse.
I was just gonna say I'm gonna go search Thingiverse.
Yep, there are tons of them. I've seen them on there. And
have any of you played Warhammer before? Or?
I haven't played it. I know of it, but I haven't played it.
Yeah, same. I'm familiar.
I see people posting pictures of them painting them.
Like the setups the setups can look pretty ridiculous. Like you can have like a whole like dining room table with like a whole even bigger. You can have 2 dining room tables and have like a whole Warhammer game on it. It's just ridiculous.
Yeah, so I mean, I'm showing my browser. I just plugged in Warhammer on Thingiverse, and there's a ton of stuff. This is just one page.
Oh man, that's crazy.
Yeah, there's tons of stuff, man.
Look at this thing.
Wait, you got to talk, Nate.
Huh? Sorry. There. Can you see now? Oh, it's still loading anyway. Ding, ding, ding. There you go. Look at that thing. It's like this big I don't know, submachine gun or something.
Actually, I saw on Reddit someone printed out like a 1/8 scale cannon that shoots Nerf things.
I've seen
That's-
I've seen people 3D printing like actual pieces for firearms, right? So this is the crazy stuff you can get into. By the way, I don't know that that's legal, but
That symbol on the side of the gun makes me think of, I think it was Skyward Sword. It kind of looks a lot like the. I'm trying to look that up. Hold on.
Yeah, the whole firearms thing is a whole nother debate.
yeah, right. I don't
Trying to
recommend you go
print
get a 3D printer to print firearms. It's probably a bad way to go.
That would be they're bad decisions. Shit, you said something else that made me think of something and I forgot. Oh, there's a guy who has a company, and I saw a YouTube video on it. He makes modifications for Nerf guns, and then he also makes his own Nerf guns that are all 3D printed, and he has a whole 3D printing farm.
That's cool.
And it's in a warehouse, and he's got literally a wall of 3D printers, and they just run 24/7. It's just printing.
That's awesome.
That's what I should do. I should replace the springs in my Nerf gun so it shoots harder.
So it leaves welts? Is that the goal?
Well, his guns use what do you call it? Motors, brushless motors with like some kind of foam wheels or something, and then
Wow.
it shoots the darts out that way.
Nice.
It's nuts. Like full auto clips, the whole thing. It's insane. It falls on the list of things that I may have thought of at one point in my life, and I was like, nah, nobody would pay money for that.
That would be awesome, but who would pay me for it? I'll just go off and start my career.
Yep.
I know the feeling.
List.
I know the feeling.
Endless.
All right, so I think that's the end of our 3D print chat, unless any of you have any more comments you want to throw in there. Once again, there's nobody asking questions on the chat. I don't know if anyone's actually watching the stream. Looks like, well, it says 2 people, perhaps, or one person. It's probably me. It's me. It's me monitoring the stream.
Maybe it's Rando. Maybe he's like at home.
Yeah, at home, sick, monitoring the stream. Like, these amateurs, I could have done better. All right, so I'm going to go back to that waiting screen for a little bit. This has been a fun little chat about 3D printing and the wireless stuff that Dan was talking about. Pretty cool stuff. So, let me go back to here. This has been fun. Like I said, folks, if any of you want to join up with our DefCon meetup, I mean, at the moment, find us on Twitter. It's like what, at DC610, or is it at DefCon 610?
I think it's at DefCon 610. And
Yeah.
also, if you want to join, we have a very, very active Slack.
Yeah, that was my next comment. So find us on Twitter to find out how you can connect with us. We have a Slack workspace that we all get together and chat on, which may or may not be moving to a Discord workspace. We don't know yet. But
for now, we're on Slack.
For now, we're on Slack. And that's basically how you're going to get the most up-to-the-minute information about when we're going to meet and stuff. You can also find us on Meetup, so when we start meeting again in the real world, you can, know when that's going to happen. And yeah, come join us. Two Rivers is an awesome place. You can get awesome beer and awesome food. And we go there once a month, and they let us hang out in one of their private rooms, and we drink a lot of beer, and we eat a lot of awesome food, and we talk about hacking.
Yep.
Oh, question.
And we play Wipeout.
So when exactly are in-person meetings going to happen again?
We still don't know.
Your guess is as good as, what's his name? Dr. Fauci's.
Okay.
So pretty much as soon as the world is safe again. I mean, you could argue that we could probably start having meetups again, but with things with COVID cases on the rise again, it just doesn't seem prudent. So we're going to wait until the world reopens, and then we'll start having in-person meetups again. I can't wait, to be honest.
Oh my God, me too.
Cool.
I just I don't know about you guys, but like I haven't lost my job during COVID, and myself and my family have been supporting, you know, local businesses best we can. Like we buy from Two Rivers, we get food from them, Porter's, Daddy's Place, like all the time.
Yeah. Yeah, I mean, you want to talk about nerve-wracking. I started a new job just a few months before COVID broke out. It happened to be for probably one of the best places I could have been at. Things have not been impacted at all at Red Hat. It's been great. I mean, the big difference is I don't have to travel now, which I don't really like doing anyway.
Dude, that was a commute, bro. Nate used to drive, what, an hour and a half?
An hour. 2 hours
An
a
hour.
day if you count the commute home, too.
Yeah.
To get to work.
An hour each way to work. Insane. I've been there, though. So.
Yeah, I'm about that.
Yeah.
So I'm happy being home.
All right, so thank you anyone who did tune in to the live stream or anyone who's watching this after the fact. We'll probably be back in a month. I don't know if it'll be on this channel or not. Danny might be back with the Land of the Living. And then, you know, we'll be meeting on, what, Second Order Chaos? Is that where,
Yep.
Is that what he calls his stream? On Twitch. So, but yeah, if you follow us on Twitter, you'll find out where to watch us when it comes time. So until then, see you, folks.